Okay, so we have we have a MacBook Pro. Um, by the way, it's been a while since we last did a record. Okay, I suppose I'll say we are back now. So we have a device. It says fan runs high. It's a MacBook Pro, and the model number it's A1989. Okay, so A1989, it's a T2 device. A1989. It's a 2018 2019 device. So the background of this device, we were told that a battery was replaced on the device, and then afterwards the fan started running crazy. So before we go into this particular device, I'm just going to explain. I'm just going to talk about fan function in general. So I'm going to explain it so that when you have an issue regarding fan being too loud or your fan's not working, so I just want to try to explain what you need to look out for when you're working on devices that have fan related issues. Now, to do this, you really have to be able to understand the year of the device that you're working on. So I'm going to kind of divide the device into two categories. Category A will be the non-T2, which is the T1 devices, and that's going to be from 2017, and that's going to be for 2017s and below. And then you will have 2018 and above. Now, 2018 will be T2 devices, and obviously from 2020, that's when you have the M series. So the M series and the T2 devices are going to be categorized as one. The 2017 and below, they'll be categorized as what? As one. Now, in the 2017s, they use T1s, which also means that they will have an SMC, which is a system management chip. The SMC in T2 devices, the SMC is built into the T2 chip itself. So 2017s and below, they have an SMC. Now, 2018 and above, the SMC it's now built as part of the T2 chip. 2017 and below will have a separate SMC. We'll have a chip which is going to be the SMC. So, for example, I'm just going to go to my board view. I'm going to take a MacBook Air. So this is a MacBook Air 2020, and the board number is 820-01-958. Now, this is going to have an SMC. This is going to have a T2, not there will be no SMC. It's T2 here. I'm just going to quickly confirm where our T2 is going to be here. On the side, let's see where our T2 is on this board. Okay, so this is going to be our T2 on this board. U3900 is going to be our T2 on this board. Now, let us, so this now, because it's a T2 device, it means the SMC function will be built as part of the T2 chip. So there will be no separate SMC. Unlike the 2017s and below, it will have a separate SMC and the T1 chip. So so let's say we can take 820-00165, which is a 2017, same model number for 2015 MacBook Air A1466. Now this is now with A1466 here you have a U5000, which is SMC. Now the reason why this is important is when you are dealing with your fans, your fans are designed to work in a very particular way, and it's important to know what type of board you're working on. Now, depending on the type of board you're working on, that will determine the behavior that's expected from the fan. Now, with SMC boards, what's going to happen is the fan is going to be controlled by the SMC. But then, if it doesn't have if you're dealing with a board that SMC is integrated into the T2 chip, it means that the T2 will now do the control, which will take over the function of the SMC. It would then mean, for example, a very common example is this. I'm going to show you guys now. Now, this is an A1466. It's the MacBook Air board. Now, this is a fan connector, which is J6000. Now on J6000, this is the connect. This is where you plugged your fan to. Now your pin 6, it clearly says not unconnected. Pin 5 unconnected. And then one of the reasons why this is important is, say for example you were busy with something and then this and that, these parts are broken off. You don't have to worry, because whether they're giving stability to the connector itself, they're not playing a functional role to the connector. So if for any reason you have this and that broken off, you don't have to worry. Now where you however have to worry, it's this here. So here you have 1, 2, 3, 4. So in the sequence you have pin 1, pin 2, pin 3, and then pin 4. Now each of the pin, they have a dedicated job. Now pin 1, that is the power that the fan runs off. The fan, the power for the fan is on your what? Is on your pin 1. And then you can clearly see there it says PP5V_SO. Now it says here that you are supposed to get 5 volt on that line. Now once you get 5 volt on that line, it means that the fan, it's going to get power. Now I'm going to pause there and then I'll come back to that. Now just something else again, you have PP5V_SO. When are you supposed to measure 5 volt on this line? Only when the device is in SO state, which is when the device is on. If the device is not on, then you will not have 5 volt here. There are other sections of the board where you have PP5V, but it will probably say _S5, which would mean that you will have your 5 volt there even when the device is not even when the device is not on. But in this case, it says PP5V_SO. And that will mean that only when the device is the device is on, that's when you will get 5 volts there. Okay, now the next one we have, pin 2 says fan_RT_T TAC. Now this is a signal. It says fan, which is referring to a fan. RT is rotation, and then TAC is the tachometer. So basically what this signal is going to do, this signal is going to report the state of the fan to the SMC. How fast, how much speed that the fan is giving at a particular time, it's going to be reported to the SMC. Thereby, the SMC can then regulate the fan through fan rotation PWM pin. So the state of the fan is going to be reported by pin 2 to the SMC. Then the SMC will use that information to now regulate the fan through pin 3 of what? Which is fan rotation PWM. Do you understand? Now, then obviously you have ground. If you have issues with either 1 or 2, it will affect the overall function of your fan. Now, I'm not sure I'm able to condense everything about your fan in one video, but I'll try. It's very it's a bit tricky. If you don't understand it, you might misunderstand one thing for another, but I hope I can try to do justice to it. Okay, so I say I'm going to come back to that. Yes, I'm still going to come back to that. So you have 5 volt here, and then fan_RT_TAC. So that is the information that goes to your SMC. That the SMC then uses that information to control your what? To control your fan. So that is going to be what goes to your SMC, and this is what going to be what comes to the fan. So this is going to go to your SMC, and then this is going to come from the SMC to the fan, and then this is your ground. Okay. Now, the way the MacBook Airs 2017 down to 2010, the way the fan will behave is this. The MacBook Airs will behave differently from the MacBook Pros, even though there's a difference of the T1 and the T2. Now, the changes, the behavior that you get on MacBook Airs is the same from 2010, let's say from 2010 down to 2017. That behavior is the same on MacBook Pro from 2010 to 2014. I'm going to take that again. The behavior you get, the fan behavior you get on your MacBook Airs will differ from your MacBook Pros. You will have the same behavior on MacBook Air from 2010 to 2017. That same behavior is what you will find on MacBook Pros from 2010 to 2014. Now, what is this behavior? This behavior on the from 2010 to 2015, immediately you get 5 volt. Immediately you have 5 volt here. The fan gets your connector gets 5 volt on that connector. The fan will start spinning. Do you understand? Now, obvious, when it starts to spin, then again you have reporting from your fan rotation tachometer, which will then go to your SMC, and then your SMC will now regulate how the fan should behave. Correct? That is the behavior you will expect from your from 2010 to 2017 on MacBook Airs. From MacBook Pros, this is the behavior you will get from 2010 also to 2014. However, 2015 will behave differently. 2015 will the fan will work on sensor base, meaning the fan will not just, you won't just get the fan to, the fan is not just going to spin just because you have 5 volt on the power line. No, the fan will only spin when the control comes from the SMC. I don't know if you understand. The difference being, the MacBook Airs, you have from 2010 to 2017, once you get 5 volt, the fan starts to spin. Correct? However, the MacBook Pros, from 2010 to 2014, it will behave exactly the same thing. From 2015, there is a difference. Even though you have 5 volt on your power line, the fan spinning is going to be dependent on the control of the SMC. Do you understand? Yes. So the SMC will basically do the control will come from the SMC. Unlike the previous design from 2014 down to 2010, once you have 5 volt or once you have power on your fan connector, it spins. Now this is true on MacBook Airs. Now from 2018, the difference that was done on 2015 devices, that difference was implemented on 2018 and above. So the same behavior that you get on 2015 MacBook Pros and above, that difference was only followed by MacBook Airs from 2018. I don't know if it's clear. So the behavior yeah. Yes, from 2018 and above. Do you understand? Yes. MacBook Pro, that behavior started from 2015. Even though, now, don't lose the fact that they are still both being controlled by SMC. Now, from 2018, Pros and Airs from 2018, that because the board itself has no SMC, the SMC is now built as part of the T2 chip. Do you understand? So if you're working on a machine, and if it's a MacBook Air 2017 and below, and you have power on your device, which is the device is in SO state, your fan must spin unless there is an issue. Now, this has nothing to do with you having a different issue on your board. We are only talking about the fan circuitry. You understand? Now, this is how your fan is going to behave. So now, what will happen now is I'm just gonna try to repeat it again before I move on. So for MacBook Airs from 2010 and 2017, immediately you have a power on the power line, the fan is going to start spinning. On MacBook Pros, from 2010 to 2014, immediately you have power on the power line of the fan is going to start spinning. From 2015 and above, the fan is not going to spin unless being told to do so by the SMC. Do you understand? Now, do you have any question? It's more on fans, but I hope I'm not going to lose you guys. So do you understand? Just before, so the main difference is the reason why I'm trying to separate it 2017 and below 2018 and above. It's the control now. Control is being done all through 2017, whether it's a Pro or the Air 2017s, the controls are still being done by the SMC. However, 2018 and above, the SMC function is now built into the T2 chip, which would then mean that the control will not come from the T2 chip. Is that understood? Okay, so do you have any question? No. Okay, before we move on, how does the fan work? What happens now? So let's say immediately you get 5 volt on the fan on the connector, what happens is the fan will start spinning. But then the speed of that fan is now going to be regulated by your what? By It's now going to be defined and regulated accordingly by the state of your board, which will be assessed by your SMC. The fan, it's a very tricky aspect to understand, especially for somebody who is new to this. Now, I'm going to say that again. The speed of the fan, you remember immediately you have voltage on your, it might, I mean, depending on the board you're working on, you probably might not, maybe some board you get, whether it's a 5 volt or 3 volt, it doesn't matter. So long you get voltage, a voltage on the line, you will get the fan spin. That's for pros 2014 and below, for airs 2017 and below. Now, immediately you get voltage on your connector, the fan will start to spin. Then what happens is the SMC will now regulate the fan according to the state of the board. What do I mean? Of what affects the state of the function of your fan is the sensor management of that particular board. Say for example, so remember the fan, the work of the primary function of the fan is to basically provide cooling to the system, correct? Now, the SMC will increase and decrease the speed of the fan, regulate the speed of the fan according to the state of your board, correct? Okay, so that's what's going to happen. So your fan is going to speed, your fan is going to respond to according to the control, or according to the state of your board, which is being determined by your SMC. Okay, now you have a problem, and then they say, let's take an example of, we are going to take two examples, a MacBook Air 2017. They say the fan overspins. Okay. This is a part where you have to be very careful, otherwise you probably not understand it. Okay, so how do you determine, so when you have a problem with your fan, that can also be divided. It is either a problem which is related to a sensor of that machine, or the problem is related to the overall control, which is the circuitry of the fan itself. So if you have a problem, if you have a fan issue behind door number one, behind door number one, it could be that you have a problem in the fan circuitry itself. Behind door number two, it could be that you have a sensor issue on the board, which then allows the fan to behave in response to the sensor issue of the board. In this case, the SMC or the controller of the board, which can either be the SMC in terms of non-T2 devices, or T2 in terms of T2 devices, to allow the fan to work at maximum speed, because it's trying to combat what it sees as excess work of the board. How do you differentiate both? How do you know that the problem is not within within the fan control circuitry? And how can you tell that the problem it's sensor related? Because at both times, what will happen is you will have the fan running at top speed. You need to know, because that way you will channel your troubleshooting accordingly. If you're not able to tell which is which, you might be chasing down a circuitry, a control circuitry issue, when your problem is it's a sensor issue. Do you understand? So how do you tell? One of the common ways you can tell is this. If the problem has to do with the fan control circuitry, correct? The machine itself will work 100%, and you only have a problem which is only the fan being loud. There will be no lagging, the device will not be slow. Do you understand? The device will not be slow and the device will not lag. That is if you have a problem with the fan circuitry itself. But that can also be divided in two. let's not go into that. If the problem is sensor based, what will happen is the device will lag. You will not be able to use the device as you would regularly do. So in other words, you'll have two problems in one. Yes, you have a loud fan, at the same time, the device is almost unusable. Do you understand? In that case, that is when you have a sensor issue and not a fan issue. The fan is only responding to the state of the device, which is overall controlled by either your SMC or your T2 chip. Do you understand? This is just one of the ways you can quickly tell that, okay, my problem is sensor based or my problem is fan circuitry based. Do you understand? So one issue, fan circuitry based, you will have your fan, your machine will work 100%, but then you have a fan that is what? That is very loud. Now the other issue will be where you have your fan is loud, but at the same time your device is almost unusable. Now, there are some times where you can tell that this is indeed a fan issue, correct? Now I'm just gonna this one you have to be you have to be very careful as to pick it up. If it's a fan issue, immediately the fan gets power, it ramps up. So if the problem if it's a fan circuit, if it's a fan control issue, immediately the fan gets power, it just goes to the max. If it's a fan issue, but then if it's a sensor issue, the fan will start normal and then gradually increase. That tells you that the fan has no problem. The fan started normal. But now the increase is coming from the controller now, which is either your SMC or your T2 now. So as the fan starts, the device starts, you have power on your fan, and then what happens is the fan gradually increases until it goes to the max. That is a regulation being done by your controller, either your SMC or your T2 chip, reading the overall of the totality of the system now, which is not the same if the problem is your fan. If it's a fan control issue, immediately the device gets power, immediately your fan just goes to the max. Because now that's not the same in terms of, remember, your controller will have to read the totality of your, you have to read all of the sense of basically it will read the entire sensor of the device. And if it finds any of the sensor that is probably not reading as it should be, that's when it would now gradually increase your fan in order to match to what it has read. But but in terms of when you have a fan issue, the control is not, it's not going through all of the sensors. No. Immediately gets power, because immediately what happens is the fan quickly goes to max, because there is no control at all in terms of the fan circuitry. I don't know, too many stuff, correct? Yeah. Okay, so that is how you can easily tell that, okay, yeah, this is a fan issue, and that is also how you can tell, okay, this is an SMC. If it's a fan issue, a fan control issue, immediately you connect power to the device, immediately the connector gets power, immediately the fan will go to the max. If it's a sensor issue, it will gradually increase. Do you understand? Yeah. If it's a sensor issue.
No, if it's
the fan circuitry. Yeah. So it will work normal. Yeah. No, if it's a fan circuitry, so you only have problem with the fan being loud, but the device will work normal. But if it's a sensor issue, device will lag, fan will be loud as well. So fan, now in that case, you then have to understand the fan's being loud. Does not necessarily mean a problem with the fan. The fan is responding to the overall state of the device, which is being determined by your controller. In this case, either the SMC or the T2 chip. Now, this is the same whether you have a single fan or a dual fan. It's the same whether you have a single fan or a dual fan. Sometimes you might have, especially on the A1707s, you have one of the fans being too just ramping up, and then one of the fan, it's fine. I mean, 9 out of 10 in cases like that, the problem is not the problem is not a sensor issue, because if it's a sensor issue, now this another thing I want to say is this. Now for dual fans, for two fans, the for two fans, the operations are mirrored, meaning they work as one. Do you understand? So if you have a sensor issue, both fans will behave exactly the same way. But if you have a situation where one fan is super loud and then the other fan, it's okay, it's not a sensor issue, because if it's a sensor issue, both fans will, because now they work in mirror fashion. Both will work. So one is not going to respond to your sensor issue, but then no. Now, but in cases where you have one is super loud and then the other one is not so loud, definitely it's not a sensor issue, it is a fan control issue. Is that understood? Okay, so but obviously as we work, so much stuff we spoke about how you can the MacBook Airs 2010 to 2017, they work in a manner that immediately there is voltage, the fan starts to spin. Then that is the same thing with 20 MacBook Pros from 2010 to 2014. Immediately there is power, the fan will start to spin. That's not the same from 2015 and above for MacBook Pros. From 2015 and above, the fan, even when there is voltage on the fan, the spin is going to be determined by the controller. In this case, T1, your SMC for T1 devices. Now from 2018 and above for MacBook Pro, now the SMC, because the SMC is no longer present, the function of that is built into the T2 chip. Then what will happen is the T2 will now take over the control of what? Of the fans. Do you understand? That's where you have some devices. What happens is when you start the device, the fan spins just a little bit and then it stops. You don't have a problem with your fans. The fan spins and then stops. Don't say, oh no, I have a problem with my fan. No, you don't have a problem with your fan. It is just the control. It's the controller that determines at that time there is no requirement for the fan to spin. Okay, so that is your T1 and your T2. Now, between your T1 and the T2, the control is going to come from your what? It's going to come from the controllers. Now, again, I'm just going to come back here. So usually you will have, here you have 1, 2, 3, 4 pins. The pin 1, that is where you have power. It doesn't matter if it's 5 volt or 3 volt, that is your power line. The second one, we see where it says fan rotation underscore tack. Now that is basically the information that is information of the fan, the state of the fan that goes to your controller. That can either be your T1 or your T2. Now that information is then used to control the fan, which is now going to come through on your fan rotation PWM, and then the last one is going to be your ground. Then another thing I also want to say is sometimes when you connect your fan, but then the clip is opened, that can also cause your fan to overspin. That's not a problem. It's just that you did not close it, because in that way, so basically there is no proper communication. There's in this is it's getting power, but there's no proper communication there. So you always make sure that your clips are closed. So and then I said, in terms of if you have dual fans, they work in mirror fashion. Exactly what A will do is exactly what B will do. If you have one fan being loud, that is definitely not a sensor issue. That is a fan control issue. And then again, I said that in terms of fan issues, there are two main issues you need to identify. Is it a sensor issue or a fan circuitry issue? Both are not to be tackled the same way. If it's and then one of the ways you can tell, there are many other ways. One of the ways you can tell is if it's a fan control, if it's a fan circuitry issue, what will happen is your device will work 100%, but then you have loud fans. However, if it's a sensor issue, what will happen is you will have the device also responding to the sensor that is not working as it should be, which would then result in your device lagging. Now, I also now want to mention, just before we continue, now, 2017 and below, your device is going to work 100%, whether you have a battery connected to the device or not. MacBook Airs. From the T2s and above, they don't work like that. The battery will be part of the boot process of the 2018 devices on MacBook Airs, which will mean that if the battery is not connected on your MacBook Air 2018 and above, now you will have the fans being not only loud, but the device will be slow. Now, sometimes the battery itself is connected, but the battery is faulty. That can also cause a situation whereby the battery, the device boots super slow, the fans are loud, and sometimes it will just not boot at all, just because of the battery. Now, in this case, obviously, the fan is only responding to the state of the device, which is a sensor issue, correct? So, and then again, in this particular case also, the speed will gradually increase. It's not just going to speed up at 100% immediately. So that is for your MacBook Airs. Some MacBook Pros will also do that, but that is only your T2 devices, not your T1 devices. Your T1 devices, whether it's a 16 inches A4121, whether it's your A1707, whether it's your A1990, without the battery connected, your device is still going to function and your fans are not going to ramp up. But T2 devices, MacBook Airs, definitely you will find that some pros will still function without the battery being connected, but most of the T2 pros, what will happen is without the battery not being connected, they will cause your fan to ramp up, and then they will cause the device to also be slow, which again explains that the problem is not the fan. The device is only responding to the overall state of the device. Okay, so I don't know. Do you have any question before we continue? I know so much I just dumped on you. Yeah. But now, the one thing that I want to say is, especially when working on these devices are concerned, when you know exactly what to do, the work is not difficult. But when you don't know what to do, you will, yeah, you just do, I don't know, you probably mess up a lot of stuff and yeah, tell the owner, yeah, your device is sure. You give all kind, especially the worst part is if you're very confident in what you're doing. You're making lots of mistakes, but at the same time, you're very confident in what you're doing. Anyway, so yeah, if you understand exactly what to do, how to do, what will happen is you will be able to you'll be able to follow up in terms of getting the job done as quick as possible, and then at the same time making your clients happy. So, do you have any question before we go to this particular device? No question. Is it? I know there's a lot of stuff. Probably what you do is after this, you again go to it and kind of take your notes and try to understand exactly what has been said. Okay, now back to this device. Okay, so we have an N1989, and from everything that we've explained, probably you'll be able to tell what has happened here. So they said that they replaced the battery on this device, and then the device is now here. The device, after they replaced the battery, the device started. The fan started ramping up. Now, clearly, from what we have spoken about, we can tell that the problem is not the fan, correct? Okay, so not really. We cannot see. Yeah, but this is a funny thing now, because if you look at the device, you see there's no power. There's no charger connected, and the device is on. So if it's a faulty battery, very unlikely that the faulty battery will power the device. But we don't know. Let's see. That's a possibility. It could be a faulty battery, but it could also be that while they were busy, they accidentally, ripped off a particular component. We don't know. So, so let's see. So let's go to the password. Let's say hopefully it's 1 2 3 4 5. We're not sure. Let's try 1 2 3 4. And nope. Let's try Apple. Okay, so let's see. Administrator. So your password is let's say 1 2 3 4. We tried that, correct? Okay, let's try 1 2 3 4. Did you try 1 2 3 4 5? 1 2 3 4 5. Nope. 1 2. And then we tried Apple. Admin. Oh yeah. Okay, let's try admin. Nah. Okay, let's see. Let's try on this one. 1 2 3 4 5. 1 2 3 4. Okay, so we're not getting. Okay, let's try Apple. Okay. we'll probably get the password, but let's see the fan. I don't. Okay, so I don't hear the fan ramping up. Uh, yeah, I don't hear the fan ramping up. And then another way also is so it's important to rule out that you don't have issues with the fan control. You obviously have issue with something else. So another way, another thing also, sometimes you also realize that the fan kicks in immediately when the device completes its initialization, which is its boot process. Now it's booted, the fan is fine, but then immediately you put in your password, which is now ready for use, and then the fan starts to ramp up. But then we don't know exactly what this is going to be. We don't have the password. We are quickly going to get the password, and then we'll continue the video. Just quickly call and see what the password is. Okay, so we got the password. We log in now. We want to see what happens. Let's see. Firewall secure data on your desk file. You must enable firewall now to continue. Okay, I have to. Interesting. Okay, so it's important to understand that up until now we didn't hear the fans running wild. So definitely we can confirm that this is not a fan issue. At the same time, it's not a fan control issue. You understand? Because if it was a fan control issue, the fan control is not going to wait up until I have. And then another thing I also want to mention is it's also important for you to go to you come here. See, to also under your activity monitor to also see you see under your system performance here. So you see there it says okay, it's on 12. That's fine. If it's reading 20 something or 30 something or 40 something, then that's crazy. But now if you have a number between 0 and 10, that's exactly what it should do. It will then obviously increase according to the amount of work that you're doing. And then so far we see that we not, although we're getting okay, so we're still in between 0 and 10. So okay, now we go to 19, 15, 7, and then we're back. Okay, so we are not, so and then we're back to 0. So so far, see the fan. Okay, so far we don't have anything with the fans. And then the reason why I say that also is this. So if you get a situation where you have your fan also being crazy, also what will happen is you will get a very high number here. You see where it shows red? You get a very high number there. So under your activity monitor also, that is also where you can also go to check. And then another thing now is this. Now in the case where the problem is the fan itself, in the case where the problem is the fan itself, your activity monitor is going to be fine because it's not pulling any extra, there is no additional power that is pulling. Your activity monitor is going to be fine, but then your fan is going to be running crazy. But also in a state like that, what will happen is the device is not going to be slow. And this one, we don't see that the device is lagging. The response is fine. I mean, if this was lagging, what would happen is you can actually see how it minimizes. It kind of, it drags to it and then it comes back. And then if you click on anything, for example, you have the spinning bar. So, but in this case, that's not what you're getting. So I'm not sure. Probably this is the wrong device they gave to us, or there is a particular type of behavior that we're supposed to expect from this. But as far as what they described is concerned in terms of the fans, this is not, I mean, the fan is not, we don't hear the fan running that loud. And in system, under our system monitor, we can also see that the number is also ranging between 0 as expected. And and then you see the CPU load is 100%. If you had sensor issue, the CPU load would probably be spiking, which is not the case. So as far as what they described is concerned, we don't see that. So what's going to happen is we probably have to reach out to them to give us more as to exactly what they meant about the fans being loud. So other than that, and then again, I'm also going to say that when you are actively busy on your device and your fans are loud, that is standard because the fan is responding to the state of of the device, especially on your Intel devices. Intel devices, they are very they are very prone to getting super hot compared to M series. And M series, they are not as hot as what as Intel devices. So yeah, so for this one, we are going to hear if there's anything more that they tell us about the device. We're going to come back and update this video. But if not, yeah, I'm just going to leave the video as it is. If you guys have any question regarding and then again, what I also try to do is whenever we're having a fan related repair, I'll also do more explanation as to kind of, to kind of throw more light into it, because it might get really confusing sometimes, especially if you just have all of the information dumped on you and you've not actually practiced on it or understood it. So for this one, we are just going to leave this as it is, and then we're going to move on to another device, and then we'll reach out to the client to find out if there's anything more that we need to understand regarding the device. Okay, thank you guys. I will see you guys in the next one.